Hello, so today we are going to try to solve this problem called number of enclaves. And then the problem says we have a 2D array and each cell is 0 representing sea or 1 representing land. And our goal is, we have a move here where a move is walking from the where a move is walking from one land square in 4 directionally to another land square or up the boundary of the grid. So we can walk from one land square in 4 directions, so up, down, left, right, to another land square, or we can move up the boundary of the grid. And we're going to return the number of land squares, so the number of ones in the grid for which we cannot walk up the boundary of the grid in any number of moves. So the number of land squares in the grid for which we cannot walk up the boundary of the grid in any number of moves. So what is happening is that we have 0, which is sea, 1 is land, and what we have is okay, so like that, and then let's take an example here from the input. So that's something like this, and we could say, so it's a matrix that gives us this. Okay. And our goal is to count the number of land squares in the grid for which we cannot walk up the boundary of the grid in any number of moves. So land is ones. We cannot walk, so we can see that we have these ones here where they are surrounded by zeros, so we can't go to another land square. We can't walk there because we have water, right? We have the sea. And so this one here is good. There are 3 ones that are enclosed by zeros and 1 that isn't enclosed because it's on the boundary. So pretty much the problem is finding like land squares and 1 that isn't enclosed because it's on the boundary. So land squares that are surrounded by zeros, or actually not surrounded, but that from which we can't reach borders. And essentially 0 can block from reaching borders. And we are not looking like for components, right? So these are just some observations. We are not looking for components, right? For components, so we are not looking for the entire components, just the number of land squares, right? So just the number of cells with 1, right? So this looks like we could use DFS here and count each cell that doesn't end up reaching a border, right? So here, well, these 2 reach the border, this one does as well, and this one does as well, right? Because it just can keep moving. All right. Okay. Okay, let's see how we can think about solving this. So definitely DFS. And the trick is going to be like if a node reaches or maybe a vertex reaches border, don't count it, right? So what we can do is define DFS here that visits a node, and if at border, right? So we will need actually two things, I and j, for a specific node. And what we can do is if we reach that border, we could just return something here. So maybe return false, right? The other option is, that may make this simpler, is what if we do find connected component that doesn't reach a border and count its content, right? So that's one possibility, right? And how can we mark the visited here? So count maybe here, right? And we could do ij, just put 2, right? And so if at border, return false, right? Or if and actually now if it's equal to 0, that means we are safe on that side, right? But we should stop, right? We should stop for that component, right? And then here we could say, we could go through the 4 sides, right? So this would be, let's call it these neighbors. So this would be I minus 1, j, and here also if at border, we just reach the border before going outside, so yeah, no need to do anything else. So ij plus 1 and ij minus 1. And then what we can do here is definitely do DFS on that, but also count plus 1, right? And if this is false, if not, then return false. That means return true, right? And then here, result is going to be equal to 0 initially, and then we'll go through all the nodes in the grid, right? So rows, columns is going to be equal to the length of A, and the length of A as 0. And then we could do for UV in range of rows. So actually, we need I and j, so I is the range of rows, and then j is the range of columns, right? And then here, if ij is equal to 1 only, that we do DFS on it, right? And then here, only if, of course, we need to send, so count equal to 0. So that means here we should definitely do count plus 1, right? So we pass count here, and only if that is true, we add count. I'm unsure about passing count this way, if it would work, but let's try it. And then we return res at the end. Yep, I didn't define a border, so let's do that. So this would be if at border would be I equal to 0, right? Or j equal to 0, or I equal to rows minus 1, or j equal to columns minus 1. So it's just return this. It would be true in any of those cases. Okay, we are not skipping if it's equal to 2. So that means we already visited it, right? So should it be false, or what if we did here just different than 1, right? So if it's equal to 1, if it's equal to 2, that means we already visited it, but that doesn't tell us anything else. So if we are at the border and a j is 2, for example, that means we already visited it. So actually, if a j is not 0, right? Because only if it's 0 that we, only if it's 0 that this, that we should return. If it's 0, only if it's not 0, that we should return false, right? Now, if we are here, that means we can say if it's different than 1, because either we visited it, so either we visited it, which means it's a 2, or it's a 0, so we can stop, right? Does count ever change here? So let's see. Print. Yeah, it doesn't. So actually, maybe we can change this a little bit. So here, instead of false, we could just return -1. And here we can return, since it's okay, let's do the simplest approach first. So let's just say false first and 0, right? And count. Return a pair here, true and count. And return false and count. And then here, return true and count. Okay. Now here, this would give us so for each valid and count, right? So if not valid, we return that. Otherwise, we need to do count +1. And then here we can say, well, DFS is going to give us valid. Only if valid, we add count. Okay. So seems like count adds too many times here. So actually count +1, right? Okay, so we have count there. Only if it's valid that we do count +1. Oh, we can do it like this, because otherwise it would skip it if it's not good. So only if A, J, and I, and J, that we count. Okay. Equal to 1, not. Oh, it would have already passed, right? No, this is bad. I would end up with a loop, yeah. So it seems like it's counting that this one here, maybe. Either that or it's overcounting this. I need to simplify this solution a little bit. So the main issue with my solution is not knowing how to keep track of the count, right? And also, like, let's see if the culprit is actually that, or am I finding two components? So valid is equal to valid, and then count is equal to count. Okay, so I have false, so it's actually the count that is wrong. So it's actually finding the right components, but it's counting 4. So it's actually the way I'm doing the count here that is messed up. So what if it's here, I just say -1. If it's here, I just return count. Also, we can stop, so just return count. Here we could say count, and if count is bigger than 0, we proceed. Is less than 0, Then we should say -1 again. And here we should return count. Right, and then we could say count and then simplify it later. So here we have count. And if count is bigger than 0, we can go. Okay. So looks like, yeah, count printed twice. Just remove that. So we have the right thing here, except we're counting too many. So one thing we can do here is, well, we could definitely start out with 1 here, and then here only if okay, let me try something different here. Let's try self.count equal to 0, and no. So if we decide that, okay, so if we decide that we're going to send 0, and then here, as soon as if ij is equal to 1, well, then at that point, so here it has to be equal to 1, because if it's different than 1, we already returned it. So here we can do count +1 and remove this and do that. So maybe this would work. Okay, cool. Now let's see with this. Okay, 0. Let's try a couple of other test cases. So maybe 1 here, 1 here, and let's put 1 here. Okay, let's see if we can 0, 0, 0, 0, 0, 1. Okay, all of them have 0. Huh, okay, so it's tricky to come up with test cases, but we have a wrong answer. This is a very long test case, sadly. Okay, looks like it didn't go far, so it seems like okay, so thinking about this more, actually, it may be a better idea to approach this differently. So this is going to be a lot of special cases here. So I'm thinking to change this a little bit, and instead of doing this, I can just pick the boundaries here and launch a DFS from every unvisited boundary if the value is 1. Float fill with zeros because we don't want to count those. And then once I do that, then all the remaining ones have to be counted, and so I just count the remaining ones. So that would make it super straightforward instead. So let's try that. So what that would mean here is, well, the very first step is float fill 1 at the boundary areas, right? And then after that, just count the number of ones. so this one should be, the last one should be pretty simple, but float filling at the boundary as well, I will need definitely to do a DFS here at, or maybe let's just call it float fill, right? And so this would be float fill turn ones into zeros at the boundary, ones into zeros starting from a position, turn all ones connected to ij into zero, right? And so to do that, well, we need to go through the boundaries, which means we need to go for the first row, the first column, last column, and last row, right? If it wasn't, right? If it wasn't float filled yet. So first row, and then we need last row, and we need to do the same thing for both first column and last column, okay? So what it means for the first column is, well, for j in range, so let's just do for both at the same time, which means for j in range of, so we need rows and columns, so that would be length of a and length of a0, and then here this would be columns, and we would need to start float fill at position 0i, and then so this is for the first row, right? So this is the first row, and then we need to do something similar for the last row. The last row is at position, so this is j, position rows -1, and then we need to do a similar thing for the first column, and so this would be for I in range of rows, right? And for the first column, we can float fill for first column, so the row is I, first column 0, and then do a similar thing for the last column. Last column is going to be columns -1, and here counting would be just go through the rows, or we could just say sum, right? Because they would be ones, right? So sum for a, right? I, j, for j in range of columns, right? And we want to return this. And then we need to do a float fill here. So for the float fill, if as soon as we encounter a 0, we should stop, right? Because equal to 0, return, and when we get to 1, j is equal, we just set it to 0, and then we need to go through the neighbors, which are, so this would be an I and j in j I -1 j, and then I j +1, and then I j -1. Okay, and then for these, what we want to do is we want to just do float fill for these position. Okay. Yeah, so that should be it. Nothing else is needed. It will be equal to 0 if it's visited, so we don't need to check that. Okay. Okay, so there is a case where in this, where we may go out of bounds, so I need to check that here. So if not, right, if it's not in the bounds, so this would be I rows and j columns, right? yeah, return. Okay. Okay, so that passes, cool. Yeah, so this is definitely a simpler idea. Just float fill the boundaries, turning ones to zeros, and then from there we just count the number of ones. Yeah, cool.